We're now doing 3-3I number 1. How do we do this problem? What do we do? Did you try the problem already? Okay, pausing.
Acceleration.
What equation are we going to use? We're going to go y equals 1/2 at squared plus b naught t, because we know how far it's going to fall, right? Then we're going to go y, oh wait, we know what y is, so I probably should write that down. What's y?
1.25.
I'm going to disagree with you slightly.
Yeah.
1/2, what's acceleration?
Do we know that?
Lead balls being dropped.
Yes, negative.
Yeah, we do. How much time?
We do know.
That's what we're solving for. What's the initial velocity while a dropped ball? 0. So 0 times t, that goes away. I can solve this, and I'm going to. I get 1.25 times 2 divided by 9.8 to the 0.5, and I get t equals 0.51-ish, we'll call it, because it's significant digits. Oh no, I got 3 digits. I apologize. 0.505-ish. That would be better. All right, good so far? Do problem number 2. Are you two discussing a problem that I asked you not to do yet?
Oh.
Seriously?
No, it is number 2. It's number 2.
Did I ask you not to correct each other's answers?
We're just discussing. Johnny Redford. Come on, bro.
Okay. Loco, what do you got for me?
I said just by like thinking common sense, it seems like if you drop a ball inside a car that's moving, like if you're going on a highway like 60 miles an hour, you like toss something up, it just lands straight back in your hand, like it doesn't get pushed back at all. So I'm thinking
So you'd make the argument it does not make the slightest bit of difference.
yes. Because it's awesome.
Negative air resistance, which makes sense. You think about it, if you are in a plane flying along at 700 miles an hour, if you drop the keys out of your pocket, there's not an incident of, it goes through the plane and kills everybody. That doesn't happen, does it? So therefore, your speed, dropping things inside of objects, shouldn't make the slightest bit of difference, and it doesn't, right? If you drop something, it makes a. So the answer would be 0.55 seconds. Is there anybody in here that does not currently believe that that's the correct answer? Okay, you now have my permission to start problem number 3. Try problem number 3. Do not correct the people around you. We need to get their questions. Do not correct the people around you. To recap, Mr. Redford.
Yes.
How can it be different inside or outside the car? What's different? You said air resistance?
Yeah.
Don't disagree with you, except that it's a lead ball, so we're neglecting air resistance. What else you got for me?
Maybe it slows down because
Why do you assume it slows down?
It's not the car.
But why? Why is it slow down?
Because it's not like there's nothing that's making it go forward. So keep going forward.
What's making it go forward inside the car?
The car.
So what will be the difference if I let go of it inside the car? It's not touching the car once I let go of it, right?
Yeah.
Is there any difference?
Yes. No.
You started from there is no difference. The answer is there is no difference. Think about it this way. Think about it this way. How fast are you going, Mr. Smith? Sitting in that chair, how fast are you going?
Well, like relative to 0 or 0.
Relative to what? Can it matter? Because if you think about it, the Earth's spinning at 1,000 meters per second, or 1,000 miles per hour. If I let go of a ball, does it suddenly go, oh, we're going 1,000 miles per hour, so I guess I'll have to. It doesn't care. Your left-right speed cannot matter. Now, we're not talking about throwing things up and down. That's obviously going to make a difference when time it hits ground, right? We already talked about that, though. Throwing it sideways does not matter. Letting go of it sideways, I should say, letting go sideways, if we've got a moving car, can't matter, right? Anybody disagree with that?
Wait, so if I shot the
No,
lead ball,
do number 4. You have my permission to do number 4. Do not correct the person's answer next to you. Do number 4. Those of you playing the home game, by the way, the answers are 0.505, 505, and 505 seconds. Ah! Stop recording.
Hi, people.
Everybody say hi. Okay, do number 4. This is Leoncio. If I have a ball in my hand and I'm going in a car driving down the road at 20 meters per second, how fast is that ball moving? Leoncio.
Oh, sorry.
Thank you. I knew he was going to say it. I just need him to say it. So, if I'm going down the road, it's already going 20. If I stick my arm out the window, still holding the ball, how fast is that ball going? If I let go of the ball, the moment I let go of that ball, how fast is it going? 20. Okay. So what's the difference between that ball that I just let go of and a ball I throw at 20? None. How long does it take the ball to hit the ground? 0.505 seconds. 0.505 seconds. Want proof, Mr. Cornell?
Yes.
In the Revolutionary War and in the wars in Europe, just before it and just afterwards, how do they fight battles? You've probably seen video of it, a fake video, right? With old men pretending to be soldiers. What do you got? How do they fight it?
They had cannons. They had
cannons?
guns that you would have.
The people that are actually fighting, what would they do?
Well, so they would have their guns, and you'd have to put a thing in it, and then you'd have to
Ram it down there, and they put a powder charge in there.
Right.
And then they go stand in lines, right?
Okay.
They stand in nice straight lines, and they walk towards each other. Now, if you, watching this in a modern sense, you look at this and go, this is the stupidest thing you ever seen. Why?
Because you're easy to hit.
Because you're easy to hit, right? These people are walking up like this and staring at each other across the field. Civil War battlefields. Not that far away, although we'll talk about why that was a bad idea. The Revolutionary War, they literally walk in nice straight lines. They'd even walk in front of you. They'd be like barking sideways, and they'd turn around and then start walking like this. And you're like, what the heck are they doing out there? Why was it safe to do that? How long would it take a muzzle-loaded weapon fired horizontally at 1.25 meters off the ground for that bullet to hit the ground? 0.505 seconds. How fast does a muzzle-loaded weapon go? About 100 meters per second. What range does that thing hit the ground? Not hitting them in the heart, hit the ground.
Like 50 meters.
Like 50 meters. Like 50 meters. Which means if I'm 75 meters away from you, I go like this all day long. You can't shoot me. You have no hope of hitting me.
Gotcha.
Which means I can stand there all day long, and guess what we're going to do? We're going to play a game of chicken. I'm going to walk a little forward. I'm going to go, want to shoot at me now? How about now? How about now? There's even recordings of people, in the writing down that Revolutionary soldiers to jump when they hear the other guns go off. Why? Because they think the bullets bounce underneath them. Right? That's dangerous by hitting you in the shin. And so they get closer and closer, and then whichever side, which by the way, usually is the Americans, went, oh crap, and pulled the trigger, all those guns would go off. They discharge a big volley. Because the idea was you hit them hard enough, and then because it took you so long to load it, you're standing, remember, 35, 40 meters away from each other? You can run that in the time it takes to reload your gun, right? So you've got a pointy stick on the end of that. You put your bayonet, you're ready to go. You fire your round, you're charging. So once you fire your rounds, what's your only option? Charge or run away. Those are the two defaults. Now, if the other side's loaded and you didn't hurt them very much, what are they doing? They're going to charge a little ways, they get a little closer, then they're going to set up and shoot you. Right? Because you can't shoot them back. It takes so long to go, right? And so they had some other things like they'd rotate fire and some other things to go along with it, try to keep that thing from happening. That's basically what it worked. They could not fire that distance. The Civil War was the bloodiest war the United States ever had. By a lot. You think World War II must have been like, no, not close. Part of it's because we were shooting each other, so you count both sides. We do the casualty count. Part of it also is the way they fought that war. They fought the war like revolutionary soldiers, right? They marched in straight lines. We've seen them. Oh, like, they get 50 meters away from each other and pull the trigger. The bullets coming out of those guns were called Minié bullets. Minié bullet goes about 230 meters per second. If I march and I stand 40 meters from you and go 90, 90, 90, shoot me, what happens?
You're going to get hit.
boom, everybody dead. And that's what happened. We had a whole unit to march out there, gives us a nice straight line, not in order to fire yet, so move a little closer, boom, everybody's dead. Like, what just happened there? That's what they did. The Civil War had 200 to 300 meters per second rounds change the battlefield. Suddenly in Civil War, we learned how to do what? Dig in. It's the first war recorded in the world where people were digging trenches. Why? People are shooting at it, get under something. Right? So it changed the war. Okay? It takes 0.5 seconds for a bullet coming out of a gun launched horizontally to hit the ground. Period. You want a sniper rifle? You want to shoot farther distance? What do you have to do? Make the bullet
Go ahead.
well, you can aim it upwards. That's really hard to do. Why? I mean, they did that. Napoleon tried to do this a couple times. What happens when you shoot? But if I got a line like this and you aim your guns up,
You're not quite sure.
if
how
you
far
don't,
they go.
now you get a much harder shot, right? If you're shooting straight at them, that's not a problem. You're shooting over them, you might miss them over the top or short, right? And so that's a much riskier proposition. So that didn't work, generally speaking. What you need to do is have your bullets be faster. All the sniper rifles that are the United States military uses, Mach 5, Mach 6 when the round comes out of the end of the gun life. Okay. The reason why is because you don't want it to drop much on the way to the target. Okay. You want to hit something at a mile, that bullet's got to be screaming because it's falling the whole entire time, just as if you dropped it out of your pocket. Right?
Yeah.
Make sense? Okay, everybody try that last problem. I think we already answered it on accident, but do that last problem. Bullet.
Hi, everyone.
If a bullet, or a ball in this case, we've got a lead ball there, we're throwing lead balls. If a lead ball is thrown at 20 meters per second, 1.25 meters above the ground horizontally, how long does it take to the ground?
0.505.
0.505 seconds. If I throw it horizontally at a speed of 20 meters per second, how far is it going every second this way?
20 meters.
Okay, so if it takes 0.5 seconds at the ground, it's going 20 meters horizontally. How far did it go? 10.1 meters, 10.2, somewhere in that range. Whatever 0.505 is times 20.
It's exactly.
Make sense?
Are you willing to bet your child that the fact is exactly 10.1?
Flip it over. Try number 6.